So number 7, I got cut off doing a video earlier, so I've already marked this up, so we're just going to have to read around that. But the instructions for number 7, 8, 9, 10, 11, and 12 are all the same. Model each scenario using a table, a graph, and a function. And when they say a function, what they really mean is an equation in function notation. So notice you'll have to do that for each. Table, graph, equation, and function notation. And they've done number 7, but I'm going to talk you through how they did it, give you some strategies. So a local arts festival has 150 vendors and 75 volunteers. Each volunteer receives a t-shirt and earns $2 for each hour spent volunteering toward a gift card for the festival. Model the value of a gift card that a volunteer can earn. Now, I find it easiest to start with a table. So the idea is, because you're dealing with concrete numbers that way, and that's fairly easy, you say to yourself, well, if I work 0 hours at the festival, then I'm going to earn 0 hours on my gift card, $0. And notice that they give you what the input and the output should be, so that's lucky. You don't even have to figure that out. Input should be time spent volunteering, output should be value of gift card. So now, if I spend 1 hour volunteering, I should get $2 on that gift card. If I spend 2 hours, I should get $4. 3 hours should give me $6. 4 hours should give me $8. And 5 hours should give me $10 on that gift card. So just reasoning through those concrete numbers is all you really need to do to get a good table. And then going from the table to the graph is fairly easy. You just plot your points. Point 1, 2 is right here. Then 2 going up 4. Then 3 going up 6. Then over 4 going up 8. Over 5 going up 10, right? Now, after you plot those points, you go ahead and draw a line through them, because you could work 6 hours. You could work 8 hours, right? You could also just work 1.5 hours. All of the points beyond and between these points are part of the function, so you draw a line, a continuous line through them. So we've got our table, we've got our graph, and now what we want to do is write that expression. So this is sometimes the hardest part. You can reason through the word problem and just say, well, what do I need to do to a variable to get that output? But another way is to look at the table and start thinking about, what do I need to do to turn this column into that column? A lot of times we think, how do we go from here to here? Right? I add 2, I add 2, I add 2. But what if I wanted to go directly from this column to this column? That's how we write that input-output model. So how do I turn that 5 into a 10? I mean, if I work 5 hours, I get $10 on that gift card. What if I worked 10 hours? What would be on that gift card? It would be $20, right? Because what I need to do to get from here to here is multiply by 2. So now the question is, what if I worked X hours? I get a little more abstract. If I work X hours, then I multiply that X by 2. The process is still the same. Multiply 1 by 2, multiply 3 by 2, multiply 5 by 2, multiply 10 by 2, multiply X by 2. So multiply the X by a 2, and that's your expression that will model the problem. So you can write f of x equals 2x. So this is how to do problem number 7, 8, 9, and 10. The instructions for 11 and 12 are somewhat the same, but it's more abstract. So I want to do problem number 11 as well, so that you can see how to do problem number 12. You're still supposed to do a table, a graph, and an expression or equation. But because this is more abstract, I don't think it's easiest to start with the table. We have the opposite of x squared plus 5. I think it's easier to actually write that out, because this is more abstract, more in mathematical terms. So the opposite of x squared plus 5. The opposite of x squared plus 5. So this is a translation exercise. So here f of x equals the opposite of x squared plus 5. And then I think it's easiest to move from here to the table to the graph. And actually, once you get that table, once you get the expression, you can actually go use, again, your graphing calculators to help you with the rest if you want. So I can take this, I can put this in, I can type in the opposite of x squared, and then plus 5. And I've got a graph right there. And if I go here and turn on the table, right, I've got a table that will help me fill that out. Now, you didn't have to do that. You could have just plugged in some numbers. I could have plugged in -1, 0, 1, 2, plugged them in here, see what happened. But since I have my technology to make this faster for me, I can just take what's written here. I can pick 4 of these and write them down. So I've got -2, 1, -1, 4, 0, 5, and 1, 4 right there, right? And then from there, and now I'm realizing that I don't have a good, this is just the positive quadrant, so I might want to go ahead and add that 2, 1 so that I have better plots to point there. So I can't actually plot this -2, 1 because that's way over here. I could estimate. -2 would be about here, -2, 1. And then -1, so notice that they're using a scale where it's 2 squares for every 1. So -1, positive 4 would be right here. And then 0, positive 5 is going to be right here. And then positive 1, 4. And then 2, 1. So my graph is going to look something like this, right? So for problem number 12, I suggest that you write the expression first, then move to the table and the graph.